It's hot.
Bill, I'm not feeling heat here. Your motivation is heat. I just need a little more energy, okay? Okay, Bill, here we go. Ready, and... Bill? Bill?
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by heat. Because without heat, you'd be cold.
When you inflate a balloon like this, you're filling it with warm air. When you inflate a balloon like this, you're filling it with hot air. See, heat is energy. So heat can do work. Heat keeps us warm. Heat makes engines run. And heat can affect molecules. Watch, we're changing solid ice into liquid water. Ah, you hungry?
Yeah.
There you go.
Thanks.
Heat moves around the universe in 3 ways. So let's take a look at the part of the universe we call the kitchen. These pancakes are touching this hot griddle. So heat can go directly from the griddle into the liquid pancake batter fast enough to turn the batter into a dry pancake. Here we have fruit cooking over boiling water. The steam cooks the fruit all the way through. This fruit is doggone good on pancakes, and the steam makes it hot, hot, hot. This is called convection of heat. Here we have a flame, and we'll roast some marshmallows. The flame cooks the marshmallows without anything touching anything. This is called radiation. So those are the 3 ways that heat moves around the universe. Conduction, conduction of heat. Convection, convection, and radiation, radiation. Not bad. Marshmallow fruit pancake order up.
Now, live from Wilmington, D.C., it's Heated Debate with your hosts, Radiation, Convection, and Conrad Duction.
Well, I'm from the school of thought that the best form of heat is of the invisible variety, like the kind that radiates from the sun.
Oh, give me a break, Ray. The best heat sources are those that move hot air up, like a fire or a warm tropical breeze. It's so obvious. Convection rules.
Connie, you ignorant slug. Heat is hottest when it is conducted directly from one thing to another. Like when you put a metal spoon into a bowl of hot soup, the spoon soon gets hot from the conducted heat.
Oh, Conrad, you hothead. Why do you think cooks use convection ovens anyway?
Oh, and I suppose microwaves don't radiate any heat. Miss Hotshot?
Hotshot? You're calling me a hotshot?
This has been another edition of Heated Debate.
Ah, che bella giornata per fare footing. Ma che ne pensi te? Ah, che bel fuoco avete fatto. E questo è perfetto per fare marshmallow. Oh, Maria, mettici il marshmallow adesso sul fuoco. Ma non la credo che sia tanta bella idea. Oops, Maria è una vittima di condizioni.
Hey, want to see heat conduction in action?
Yeah.
Well, get a bowl of hot water, stick a pat of butter on a metal knife, a plastic knife, and a popsicle stick. Then put a sugar cube on top. Heat energy is conducted up to melt the butter. Watch to see which sugar cube falls off first. The butter will melt off the one that is the best heat conductor. See? Well, what are you waiting for? Try it.
He's big, he's sweaty.
He's a guy.
He's big, sweaty guy.
Hi, I'm Big Sweaty Guy. Some people wonder how I got my name. It's really quite simple, you see. I'm big. I have more size or mass. Some people say I have a nice mass. But I have to work harder to move this mass around. This extra energy makes me hot. Hot!
The mountains are icy, but they've got motion of molecules.
Ha! See, even cold things have heat. Things like snow and icy mountain lakes and glaciers. They've got heat. Anything with molecules has heat. It's just that the molecules in cold things are moving more slowly than the molecules in warm things. You with me?
Okay, y'all ready? Sing along. It doesn't matter whether something feels cold or hot. If molecules are moving, it's something all things got. You know the words now, sing along. It doesn't matter whether something feels cold or hot.
Here's a question. Which has more heat energy? This hot burning match or this beautiful ice sculpture of science? Well, the match is hot, right? The sculpture's cold. Well, they're both made of molecules, right? But which has more molecules? Well, the ice sculpture. A lot more molecules. So although they're much colder than the match, they actually have more heat energy. More molecules, more heat energy. Think of it this way. Suppose you tried to take a burning match and use it to melt the whole ice sculpture. Well, it's not going to happen, right? I mean, the match is going to run out of molecules long before the sculpture. So, more molecules, more heat energy. Ooh, ow, ow!
Careful.
We broke the swan.
Glassblowing is all about heat. We use the heat to help expand a piece. Also, you have to know when to have a lot of heat, when to have little heat, where to heat, when not to heat. I got it. Oh, I got it. There's the finished piece. Something very hot, something very cool.
In this beaker, the water nearest the flame becomes hot. It expands and becomes lighter than the cooler water on top. As the cool water moves down, the hot water rises. This transfer of heat by currents through liquid or gas is called convection.
Welcome to another great moment in science. The year 1994. Science Guy is hot on the trail of heat. Wants to find out what natural convection is. Decides to fly in glider to find out.
Here's the idea. The sun warms the land, and the land heats the air right above it. The air molecules get going faster and faster, and they move farther and farther apart. Then the cool air comes in and pushes the warm air up, and it pushes us up with it. It's pretty cool. Natural convection!
Will Science Guy overcome the natural convection air currents? Find out in the next edition of Great Moments in Science.
My name is Andy Jessup. I'm a scientist and I study heat. What we use is a special camera here, which is an infrared camera. It's sensitive to heat radiation. Our eyes are only able to see visual light, but this special camera can see thermal radiation. It's a map of temperature. The blue is cold and the red is hot. I'd like to show you how we can see radiant heat as it heats up an object. This is an infrared heat lamp. We have a piece of black paper here, and I'm going to turn the lamp on. And as we watch the display, you can see that the pattern of heat is growing. It's getting hotter in the middle as the radiant heat is transferred from the lamp to the paper. Very cold things like liquid nitrogen at minus 200 degrees centigrade still emits thermal radiation. This now is how the imager sees something very cold. Even very cold material radiates some heat.
vacuums are fascinating.
Like this thermos, it's a vacuum, with one glass bottle inside of the other, and there's no air between the two glasses.
Exactly. And since there aren't any molecules in a vacuum, well, none of the heat in the thermos can get out by conduction.
So my tea stays icy cold because no heat is conducted into the thermos, and your tea stays piping hot because no heat is conducted out of the thermos.
Well, actually, some of the heat does get out. I mean, even though we can't see it, the bottle my hot tea is in does radiate heat. And since heat can radiate through a vacuum, well, some of the hot tea's heat does get out.
So my cold tea warms up a bit because heat radiates in from out here.
Well, back to the old grind.
Yeah, let's get this bad boy rolling.
Hey, Bill, what are you doing?
Keeping warm by the fire. But whatever side of me is facing away from the fire gets cold.
Well, you know, Bill, a very hot object like that fire is radiating heat. Heat radiation is made up of waves, just like light, that race along at nearly 300,000 kilometers per second. This fire is radiating waves of infrared light. Heat waves.
Yeah, and the hot air above the fire rises up the chimney.
Sure, natural convection. Without it, chimneys wouldn't work.
And the cold air that's flowing across the floor to replace the rising hot air makes my back cold.
That's why we've got one of these.
Hey, did you bring any marshmallows?
Oh, un caldo così non batte niente che camminare sotto alberi freschi. Per una ragazza italiana sarà un bel soddisfazione mangiare un marshmallow. Uno per te e uno per lei. Il resto va sul fuoco. Anzi, fa caldo da fuoco invisibile. So buoni, tutto da ringraziare da fuoco invisibile. Buon appetito.
Even glaciers have heat, and that makes me hot!
Here's a way you can see heat convection in your own home.
All you need is a piece of paper cut in the shape of a snake.
Yeah?
Looks like this. It's a spiral cut out of a piece of paper taped to a plastic bottle cap. You tape a pencil to a tea towel bar that you might have in your kitchen.
A what?
Take the towel off. Then push a needle into the eraser end of a pencil and balance the plastic bottle top on the end of the needle.
Put the toaster under the snake and turn it on. The warm air rises from the toaster and makes the snake dance. That's convection.
Not bad.
And now, another episode of Hot Treats with your hostess, Vivian Cupcake.
Oh, why, hello there. I'm ever so glad you could join me today, because the kitchen is such a wonderful place to learn about heat. Today we're going to cook with this metal baking pan and this glass baking pan. Say we pour half our brownie batter into this metal baking pan. This will be chocolatey and delicious.
Careful.
Mix it out. The tasty batter will turn into scrumptious brownies when heat from the heating element heats up the metal pan, and the metal pan transfers its heat to the brownies. That's heat conduction. Conduction heats the glass baking dish too. But because the glass is clear, red light and infrared light, that's heat, passes right through the glass baking dish to heat the brownies. That's heat radiation. The metal pan isn't clear, so it reflects the infrared light. Heat radiation cannot heat up the brownies in the metal pan. That's why we cook our brownies for a longer time when we use a metal pan.
You want to, watch it. Careful now.
And this is my favorite part of studying heat. Oh, that is hot.
This has been another edition of Hot Treats with Vivian Cupcake.
Just how hot in calories or joules. That's right. Sing it out. The hotter something is the master its molecule, and you can measure just how hot in calories or joules. Great, keep singing. A honor.
Clothes dryers work with forced convection. They force hot air over clothes. Moving molecules. Gloves and hats and hoods and coats and sweaters are all about heat. You say, hey, I thought they were about cold, keeping out the cold. Well, you see, the way you do that is by keeping in your body heat. Now, here's how coats and jackets work. They trap air. See how thick this is? Big, puffy pillows of air. Now, air molecules are pretty far apart. So for heat to transfer, one molecule has to bump into another molecule. The farther apart they are, the harder that is for heat to get transferred by molecules. So it keeps you warm. It keeps out the cold. You don't mind if I put this stuff back onto you? It's kind of cold here.
This freezer is cold, but it still has heat. And that makes me hot.
This is a heat pump. It can pump heat from inside the building out here into the environment, or from the environment into the building. Of course, all this pumping takes energy, and that comes from over there. So a heat pump is like an air conditioner and a heater in one. If it's a hot day, we want it to be cool inside the building. Well, the heat pump gathers heat up inside the building and forces it out into the warm environment. But what if it's a cold day and we want it to be warm inside the building? Well, there's enough heat energy out in the environment, even when it's cold, for a heat pump to gather it up and push it into the building. Isn't that wild? Isn't that cool? Cool. See?
Yeah,
the heat
got
pump.
it. Okay, let's all sing another one. Heat can be conducted and move when two things touch, or travel by convection and rise up, up, up.
Even this molten steel is about 2,900 degrees, and that makes me hot!
So don't grab red hot pokers or drop live coals on your feet, 'cause that would show you just don't know the first thing about heat. Okay, everybody sing along. Let's sing one more.
Do you ever wonder where the heat goes that your body gives off? Well, try this. Hold your hand so that your palm is facing a window at night. Now rotate your hand so that your palm is facing into the room. You can feel the difference. The room is warmer. That's because heat goes right off of your hand, through the window, to the night sky, into outer space. It's gone forever. Isn't that wild? So that means that the floor and walls and ceiling of a room are reflecting heat. Now, curtains help keep a room warm, too. Curtains also help keep out big, scary monsters.
He's hot. The heat's so neat. He's hot. Aw, he's hot. The heat's so neat. He's hot. Have you heard that everything is hot? The universe and everything it's got. The sun gives off radiation. When air gets warm, that's convection. Hot and cold aren't that different, I'm told. Molecules just moving fast or slow. When you got heat that's moving place to place, it's stuff, that's conduction, I say. Aw, he's hot.
out here. Well, that's our show. If you'll excuse me, got some infrared radiation to monitor. See you next time.
Produced in association with the National Science Foundation.
I'm melting! Melting!
Science. Science. Bill really knows science.
Can make heat go from a hot. Now, one way to keep warm. Is that what this bit's about? Keeping warm or heat?
Science.
That makes the pancake turn dry and look like heck. Well, that's our show. Thanks for watching.
Bill really knows science. Sing along. Science. Science. Bill really knows science. Yeah, sing out science. Science. Bill really knows science.